Here we go with example number 2. Okay, so here we have a word problem. The school population for a certain school is predicted to increase by 60 students per year for the next 12 years. If the current enrollment is 700 students, what will the enrollment be after 12 years? All right, so we've talked about sequences and we've also talked about patterns of numbers and problem solving and trying to think our way through a problem. So again, what I want you guys to do is to pause the video and reread the problem and just think about how would you approach this. See if you can do some figuring, and then when you are done, or if you get frustrated, then go ahead and play the video, finish it out, and I'll show you how I would approach the problem. So go ahead and pause now. Okay, so hopefully, again, you took my advice and you paused the video and you thought your way through this problem, because this is so important for us to learn problem solving and thinking skills. It's incredibly important, because there is no way in this world that you can possibly work every single problem that will be presented to you or to your students when you're a teacher. So you have to be able to think your way through the problem and come up with the answers so that you can help your students later on. Okay, so we've been talking a little bit about, formulas with arithmetic and with geometric sequences, and we could use a formula with this one, but I think it's just as easy just to think your way through the problem and come up with a common sense approach to it. Now, we do have to kind of be careful about our years, though. So what I'm going to do is I'm going to say, okay, we're starting off with 700 students. So that's our start off point. So after 1 year, if we were to increase by 60 students, that would make us have 760 students, true? So now then we can figure out what 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 years would be. All we need to do is really add 60 until we come up with that 12th year. So if I add 60 to 760, I get 820. If I add another 60, I get 880. If I add another 60, I get 940. If I add another 60, I get 1,000. Another 60 would be 1,060. And then adding again, we get 1120. Adding again, we get 1180. Adding again, we get 1240. And again, 1300. And again, 1360. And again 1420. So this would be, after 12 years, we would have 1,420 students. Now, like I said, we could have done this with a formula, but we would have to be very careful about our n, because in this case, we're starting off with an n. If we look at our very first term, it would be 700. But so we would not use 12 for our n. We would actually have to use 13, because after the first year, this is the second term. This is the third term, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th. So we could use the formula for it. If we did that, we would have to say a sub 13 equals, remember your first term was 700, plus n, which is 13, minus 1 times the common difference, which in this case is 60. And then if I were to go ahead and solve that, I would say 700 plus 13 minus 1 would be 12 times 60. So a sub 13 would equal 700 plus, now 12 times 60, that would be 720. So whenever I add those together, I get 1420. So you could have used the formula, but you would have to be very careful and think your way through about how many years it is that you're talking about to know what your n would be. Or you can just use some common logic and write out a few terms to get that. Either way would be fine.